it works. It works all together. It works pretty well. I mean, perfection is something you can never achieve, but it works pretty well now. So I realized why my movement up was not working properly, because I was interpolating between the wrong values, because I have the whole height of the movement and I have the height of the glass. And of course, I want to interpolate within the height of the glass and not the whole height of the movement. That is certainly a nice improvement I've done to the software, and I can show you here on the GUI. So here I have the vessel height. So because I'm thinking, is it a glass? Is it a cup? Is it maybe a bottle? So that's why I call it vessel. So I have the vessel height as an additional parameter, and now filling works pretty well. But what's even much more amazing, somewhere in here, which one did I want to take? Yeah, this one I wanted. I got my new stepper drivers. This is the new stepper driver I have, and this is the old one. And you see the new one has a much cooler heatsink. But that's basically peanuts. We don't need that. But I mean, it means better cooling. Better cooling is always good. But it's not just the design that's the difference. This one is 4988 or something. Quite an old stepper driver. And this one is a Trinamic 22. I don't know. But I mean, it is now a Trinamic driver, which is known to be silent. Now, listen how the conveyor sounded before. It's basically silent. It's amazing. We have all the noises gone now. That's pretty cool. And I'm looking deeper into these little stepper drivers. There is another version of these that even has stall detection, so it detects when you hit an end stop. And if I can get this to work, that would mean that I can take out all the sensors I used for referencing. I mean, that's technology my Prusa has been using for a while now, but I didn't realize how easily accessible it is to me. I mean, it makes a difference. That little thing is about $1, and this one is $2.50 to $3, so it's 3 times more expensive. But between $1 and $3, it's still negligible, but that's pretty cool. And now let me show you how we can fill stuff. I need, of course, switch to the automatic filling mode, because I was in the conveyor testing mode to show you the conveyor. So in the right mode, move over the scale, move down the tube, fill, and out. And next. And now in my GUI I have also an option. It's this option here, push the full glass out. Because I have 2 possibilities to use that. I have this off ramp here, and this off ramp allows me to push the glasses over the ramp. So basically I can continuously fill. I still have the issue that at the end of the ramp the glass falls over, but basically the software can do it, and I have to optimize the valve. I have to optimize the ramp. If now, without push out activated, I put the glass here, the whole system will detect, oh, there is something at the exit. We don't want to push stuff out. So accordingly, it will wait until I remove that one. And then the whole filling process starts over. If I take out the glass at the end, I have no glass at the entry. Obviously, the machine will also do nothing because there's no new glass coming in. So you don't want to run your system if you have no empty glass coming, because that means a mess. The sensor inside the scale, I also have a sensor where the scale is, where I fill. That sensor, I need to redesign it similar to that one. And the first one to have a longer bar to better detect the glass. That is something I'm thinking about, but that's not for now. Now I can here activate the push full glass out, save the settings, and put the glass here. Prepare the next glass. I mean, that's basically the idea, is while it is filling, I can handle the glasses. That's how I wanted to do it. Yeah. It just scared me for a second. Was waiting for a bit of time. See, that's how it works. I can push out the full glasses. So, step by step, we're getting somewhere. And so now I have an output buffer, and if I work with the stack of cups, I can basically fill 4 or 5 glasses. And that's cool. You see the vibrations of my tube I pull up make the glasses slide on the slide. That's cool. So basically automatic filling works. And in a few days, I have my friend waiting. We will test that with real beer for the first time. But there's another thing I had mentioned in the last video is that the cup magazine has an issue depending on how big the stack is. So just to quickly remind you, the principle of my cup magazine is I have a wheel here and a wheel here. My fingers symbolize the wheels now. And first I move up until it slides because it's conical, so at some point it will start sliding. Then I move down, and when the wheel is at the second cup here, so about here, if it's at the second cup, I have a latch that catches the lowest one, and then I move the whole column up, and then the glass falls down. The problem is if I have a heavy column, everything is further down than if I'm coming just with 3 glasses. I have less weight, so it's higher up because it's all based on friction. And the reason I want to base it on friction is because it's more versatile. It allows for all kinds of cups. If I do something that is that needs a specific geometry of a glass, I would need to redesign the whole machine for every type of cup I have. And basically I want to be able to run with these cups, with these cups who have this border here at the edge. See the edge? And this edge is much flatter. And so that's the reason why I chose friction. So this was my old, what do you see here? This is the old latch I had. So glass comes here and catches. But since we have only one tooth here, we are geometrically very defined and can only catch at one position. So I redesigned the whole thing to be like this. Yeah, let's show it like that. And so when the glass comes here, it can either catch here, 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 here. And I hope that this length here will compensate for the variation I have in the cup stack. So that's the whole cup magazine lying here. That one needs to go in here. And what I also have added are these 2 guide rails on the sides, and there will be another guide rail coming in here. And since they are on the same screws than my guiding wheels here, if I adjust this, everything moves together. So this will be narrower or wider, always very close to the cup. And so it should help guide the cup when it's coming down so it doesn't fall over or it doesn't go besides the sensor. All these kinds of issues I had in the past. So I'm curious to test that too. So let's put that one in. Like that. Yeah, here on top I can take the short one. Faster. You see, it's more and more incremental, and I'm very, very happy about this. The big stuff is working, and now I'm starting to fine-tune the details. But it still might take a while until these details also are reliable, because I mean, reliability means thousands and thousands of cups filled with no issues, because without that, nobody is going to be happy with that machine. So, but now I can screw that one in. It's a bit tight, but it works. And now we need to adjust everything so we have the right dimensions for the cup. Yeah, so how to show on camera. Oh, let me take that one over here. Here we are way too wide, of course, so we need to move that further in. We're also way too high up because we don't want to catch up here, we want to catch down here. But for that, I have this setting screw over here, so I can move this one. I think I'll put it all the way down. Yeah, I will need to narrow the wheels also a bit. But it's okay. But I mean, all the way down is at least easy to reproduce on both sides, because that's always an issue. I have height settings left and right, and so how do you keep them equal? But since, as it seems, we have to go all the way down anyway. Ah, yeah, that looks good. Okay, and now if I go down, click. Oh, but it's not symmetrical. And who cares? It's actually even better if it's a bit asymmetric. So I wanted plugged in here first. Up. Yeah, I have a new connector for this. This one is way too massive. So, is that about the height I want? Yes, that's the height I want. And now, sort out the wires first. Now we go into the Cup Magazine test mode. And it goes too far. It goes way too far. So Cup Magazine. Oh, I already have reduced it quite a lot, but let's try again. Let's first shoot all these cups through somehow. Okay, now let's try again. Now it's not far enough, of course. Let's try with the whole stack. Biggest possible stack. Oh, all these full ones need to go back into the keg, or that water back into here. Okay. Now, next try. We're way too high. Way too high with the hooks of the jaw. Sounds like a redesign and a reprint of that part. But yeah, it's just one part, and it's actually one that's rather easy to optimize, and you don't need fluids, which makes it much easier. So I redesigned the whole thing, and I thought something. I saw an article on LinkedIn, a video of someone who was printing bending parts, so 3D printing flexible stuff. And I'm really thinking of if I could try to print the spring, because inside my latches, inside these little things, I always used that stainless steel band here, this stainless steel strip here. I used that one as a spring, but I mean, I need to cut it to the right length. It's another part to install and so on. If I could print the spring directly onto the part, I mean, that would be amazing. But the question is how durable it is. But I mean, physics say that as long as you're in the flexible range, the material will survive. The problem is that material science tells that plastic is always a bit viscous. It's always a bit flowing. So I'm not sure, will it flow or will it bend? That's the big question I need to find out. But since the 3D printer is ready to print, I can start working on that. Thanks for tuning in, and next time we will tap beer, real beer.